As the sun sets, the night sky is teeming with countless stars that we observed. For thousands of years, ancient astronomers thought that the Earth was in the center of the universe. And so they wander groups of stars, form zodiac patterns called constellations. Until generations later, the invention of optical instruments, for example a telescope, used to observe distant objects that are too far away to see. Today, astronomers will observe the universe with powerful space telescopes, and our journey will explore the extraordinary universe to discover wonders and distant worlds of these extremes that they have life that we'll find out to understand. Our journey begins in space, starts high above Earth. Its atmosphere is mostly nitrogen and oxygen. The surface is covered by 3/4 of oceans of liquid water. It teems with life. It rotates every 24 hours, still orbits around the sun for 365 days. In the perfect distance where it sits in the habitable zone for conditions for life. As we move away from Earth, our nearest neighbor, the Moon, is our first stop. The natural satellite that orbits around the Earth for a single month within 27 days. And it's just 250,000 miles. Up close, it's a gray, barren, dead landscape, covered in craters, hammered and pockmarked by asteroids. Dark regions on the Moon is caused by lava solidified from massive impacts. And 12 astronauts have walked on the Moon itself, and there could be no air, no weather, no oceans on its surface. It always creates eclipses, and its gravitational pull keeps the Earth stable enough for regular tides. But our journey will set off into an exploration of the planets in our solar system beyond Earth. Is revealed by exploration space probes. Could life, human or otherwise, survive on any of them? Near close to the sun beyond Earth, we encounter the brightest planet. Is named after the goddess of love, Venus. It is often the sister planet because it's almost the size of Earth. Up close, it's wrapped in a thick layer of clouds. But those clouds are poisonous, mostly sulfuric acid. And the atmosphere is choked in carbon dioxide. Greenhouse gases trap the sun's heat, making it 860 degrees Fahrenheit, hot enough to melt metals, including lead. And the pressures are 90 times greater than it is on Earth, enough force to crush a submarine. And its surface is made of landscapes, valleys, and volcanic activity. Perhaps even lava. any human being survive in this nightmare environment? Conditions here are very inhospitable and deadly. Nothing can survive there. As we move closer to the sun, temperatures become hotter here. Until we encounter the closest planet, Mercury, around 36 million miles. Only slightly larger than the Moon, this planet is a heavily cratered world. In daylight, scorches hotter than the oven, and temperatures at night plunge below zero, colder than liquid nitrogen, and it orbits around the sun within 88 days. Moving out from Mercury, 93 million miles in the heart of the solar system, is our star, the Sun. A medium average yellow star is a hot ball of gas and plasma, reaching 10,000 degrees. It's so enormous that you could fit 1 million Earths inside, but the core in its interior reaches millions of degrees. Hot enough for hydrogen and helium converted to energy that powers the star. Its surface also dominated by solar flares and prominences, and spell out deadly ultraviolet radiation and solar winds. Moving outward from the sun, we encounter a comet. An icy body dislodged from the cold distant regions gets too close to the sun, and the heat bakes a frozen lump of rock, and a stream of charged particles from the solar wind blows away the evaporating gases from its nucleus, forming a tail, making it visible from Earth. Until we travel beyond the Earth's orbit. Then we encounter another planet is known for its reddish appearance. The god of war, Mars, the red planet. Its reddish color is mostly iron oxide or rust. Although smaller than Earth, it has a thin atmosphere. As we approach the surface of the red planet, conditions here are cold and inhospitable, but its surface is made of landscapes, valleys, canyons, and giant volcanoes. A vast deep canyon is wide as America is Valles Marineris, and dust storms cover the regions around Mars. And we approach its most distinct feature, the largest volcano in the solar system, Olympus Mons, is also 3 times taller than Mount Everest. And robotic probes explore its details on the Martian surface. But Mars did not look always this way. That scientists believe that Mars was once covered in oceans of liquid water, conditions for supporting microbial life. billions of years ago. New evidence suggests that the still remaining water can be found hiding in the Martian surface, or perhaps in the ice caps, and it's possible that it can be found beyond the Mars. We encounter a belt of asteroids. These millions of chunks of rock are the leftovers from the formation of the solar system, in the border between the inner and outer planets. They can be arranged from a pebble to boulders hundreds of miles in diameter. They sometimes get dislodged from the orbits. Beyond the asteroid belt, we encounter the king of the outer giant planets, Jupiter, the largest planet in our solar system, more massive than all of the other planets combined. With no solid surface, this planet is entirely made of gas. In its turbulent atmosphere is an enormous storm, is the Great Red Spot. A huge, rapidly spinning hurricane bigger than Earth has raged for 300 years. It's also been observing since the invention of the telescope. Its composition is mostly hydrogen and helium gas, with its stronger gravitational pull that dodges asteroids, and it's circled by a diverse family of moons, and the largest in their own right. One of its moons, Io, is pockmarked by constantly erupting volcanoes spewing sulfur. And the moon Europa is covered in ice, with cracks and channels that can be traces of oceans of liquid water. Is hidden below the icy crust. Perhaps there may be undersea alien life. And Ganymede is the largest moon in the solar system, bigger than the planet Mercury. Beyond Jupiter, we encounter the second largest planet is the jewel of the outer solar system, Saturn. Around 830 million miles, Saturn up close is easily visible with its bright rings. It's less dense and the same composition as Jupiter. However, the rings may look solid, but in fact, they're mostly billions of chunks of ice and rock, ranging in size from a pebble to lumps are big as a car. Unlike Jupiter, Saturn is circled by minor moons. And one of them is the largest, and it's wrapped in an orange hazy atmosphere, Titan. beneath its nitrogen-dense atmosphere. Its surface is covered in oceans of liquid methane that feed in rain, lakes, and rivers. And there can be traces of organic molecules are found on this alien moon. What lies beyond Saturn? The sun becomes dim and temperatures drop to freezing. Around a billion miles away, we encounter Uranus. Its unique rotation is spinning on its side at 98 degrees. Was a result of a planetary collision, and it's a typical ice giant. Beyond Uranus, around 2 billion miles, we encounter the last of the outer planets, Neptune. Its blue color is mostly methane gas, and its ferocious winds is about 1,000 miles per hour. We encounter one of Neptune's largest moons, Triton. Its active surface is erupted by blasting geysers of liquid nitrogen. Was discovered by the Voyager 2 spacecraft. Beyond Neptune, in the cold distant regions of the outer solar system, we encounter a vast belt, teeming with millions of icy objects, and dwarf planets like Pluto and its moon Charon. Only slightly smaller than our moon, it's too small, not big enough to have its right size. The sun, almost 4 billion miles, is so dim it appears just another star in the cold distant regions in space. However, Pluto's not alone. It's just one of dozens of dwarf planets in the region of the Kuiper Belt, where astronomers discovered, like Eris. And the most distant body is Sedna. And we encounter the farthest space probe, Voyager 1, accelerating far into interstellar space. And beyond, we approach a vast cloud. It's teeming with billions of icy comets, leftovers from the formation of the solar system. If space probes like Voyager 1 reach the nearest star, it would take tens of thousands of years to get there. But at the speed of light, it would take a few years until we explore the stars beyond our solar system. Beyond our solar system, we reach into interstellar space. Around 4 light years away, we encounter the nearest stars, Alpha Centauri. We're traveling faster than the speed of light. We measure in light years. We pass through countless stars. Distances are so vast, they're mind-boggling. Every individual star requires nuclear fusion that powers its interior, emitting more energy and light. As we encounter the constellation of Orion, we approach a nebula around 1,500 light years away. This stellar nursery is a massive cloud made of gas and dust. Within this vast cloud of gas and dust, new stars are born. Clumps of clouds are condensed. When the temperatures become so high, new stars begin to shine. And after stars were condensed in a great cloud, their powerful lifespans in millions and billions of years. And we approach the Seven Sisters, the groups of 7 young stars. Around 7,000 light years, we encounter another stellar nursery, the Eagle Nebula, a vast cloud of these towers of dust and gas. In these pillars of creation, where stars are born within in these clouds of hydrogen. And some other stars have their own planetary systems. Worlds of rare forms of matter. However, if these exoplanets have the right conditions, alien life could possibly exist. Then we encounter a distant solar system. It's Gliese 581, around 20 light years away. Within the constellation of Pegasus, around 50 light years away, some of these planets, perhaps a gas giant, orbits too close to its parent star. Its atmosphere is boiled and escaped into space by the solar wind. If stars are small, some are average, yellow like the sun. Others are small, red, cooler than the sun. But stars in their lifespans don't last longer. Small stars are average like the sun. The fuel that powers the star is used up. They become into red giants. And once the interior is manufacturing more heavier elements, they become unstable, expelling their gases, drifting into deep space, forming a planetary nebula. And in the center of the planetary nebula, the core remains of a star is now a white dwarf. And we encounter the Ring Nebula, around 2,283 light years away. When stars are more massive than the sun, they become into red supergiants. Its fuel that powers the star is used up, burning heavier elements in its interior. When the cores collapse, the star becomes unstable until it explodes violently, a supernova. The enormous explosion scattered away gas and dust and the elements into space. In the heart of the supernova is the remains of a collapsed nuclei, a super dense pulsar. It's around 12 miles across. It spins rapidly, that blinks from the distance. The Crab Nebula is a supernova remnant. It's around 6,000 light years. And the objects are far more denser than a pulsar, a black hole. And that neighboring star is distorted out of shape into the heart of darkness. The remains of a collapsed core of a massive star. The region of space-time is where the gravitational pull is so strong, not even light can escape. Moving ahead around the galaxy, some of these stars are in binary pairs, and we approach a vast nebula. Within this vast nebula, we approach this large cloud of gas, is blown outward by its central star, Eta Carina. And as we move much farther, all of the stars, planets, and nebulas are all packed together in a vast swirling galaxy that comes into view, the Milky Way. The enormous spiral galaxy, the Milky Way, is around 100,000 light years across, containing 100 billion stars. And our solar system is located on one of its outer arms of the galaxy. Around the Milky Way is surrounded by countless globular clusters and dwarf galaxies like the Magellanic Clouds. And out beyond the Milky Way, around 2 million light years, is another spiral galaxy, Andromeda. Andromeda in the Milky Way and dozens of smaller galaxies form a cluster called the Local Group. And beyond the Local Group, the Milky Way is one of thousands of galaxies that are spiral, elliptical, and irregular that make up the Virgo supercluster, around 60 million light years away. It's also widely separated apart because the universe is expanding. Among other galaxies, we approach this large elliptical galaxy, Messier 87, has a supermassive black hole in its center. And beyond, the Virgo supercluster is one of thousands of superclusters and the billions of galaxies that make up the universe. Each individual small dot is a galaxy containing countless stars, the numbers of grains of sand on Earth. And the billions of light years away from home, the brightest objects are quasars. They can be observed in most powerful telescopes. And we approach the edge of the universe. The entire universe is absolutely big, mostly 93 billion light years across. Finally, as we return back home, we're back, that we started our journey, that we explored the cosmos and beyond. And our tiny Earth, orbiting this insignificant star, remains for us in the universe, the most inspiring planet to have complex life.